So, friend, let's start. It says every day is a good day. So, is today. And enjoy and have happy learning. And hopefully, we will have a wonderful time in this particular session. Let your unique and also smile and positive energy make all of us energetic. Any questions if you have before we start? Any doubt, any query if you have about what we discussed yesterday? Any questions, any doubt if you have?
Any doubt, any question to last day session? So please you ask. Sir is ready to reply your questions. So please go ahead.
No. So let's go ahead
Okay, sir.
and let's finish the unfinished agenda of the yesterday. And if you remember, we were talking about violation of assumptions, and we covered violation of assumptions about the mean of the error term is not zero. And we take care of this problem by introducing alpha in our model or by introducing the intercept in our model. If we don't have intercept in the model, it may be possible that my estimates become biased estimates. So if a constant term is included in the regression model, then this assumption will never be violated. Hence, we should not worry about this particular assumption. And if we do not include intercept and error term does not have a zero mean, then it may lead to severe biases in the estimation of the slope. Then we discuss about what if my error term does not follow a normal probability distribution. So what are the consequences of it? If my error term does not follow a normal probability distribution, we will not be able to make use of t-test, f-test, chi-square distribution. Hence, we will not be able to do any kind of hypothesis testing and any kind of interval estimation. So problem will be in the hypothesis testing and interval estimation, nowhere. My estimates will be still blue. They will be best linear unbiased estimator. And we can get an idea about normality by looking at the basic statistics. We can make QQ graph, histogram, KS test, and Jerick-Berer test. And we have seen how we do it in Gretel. So if my distribution is not normal distribution, what should I do? If my sample size is large, I should not worry about it because the central limit theorem will apply, and that says as the sample size is increasing larger and larger, your distribution tends to follow a normal distribution. And if I'm only interested in the estimate, then normality is not a concern for me. If the sample size is small, then we should take care of the outliers and we should remove the outliers in order to get the normality of the data. Or we can do some kind of a transformation, like we can take the log of the distributions, log of the variables to ensure that the ultimate distribution is normal distribution. Okay, so that's how we will take care of it. And I think that was the point when we stopped yesterday. Still have Still you have a doubt or a question, let me know. Any doubt, any question if you have? Prachi, Nishant, Renu. Okay, no. So let's move to another very, very important violation of the assumption, and that is what if my variance of the error term is not constant? If the error term variance is constant, we say homoscedasticity. Homo means constant variation. And if it is not constant, we say heteroscedasticity. That means my variance is not constant and our model is suffering from what is called heteroscedasticity. So what we should understand heteroscedasticity. Heteroscedasticity is a situation where our assumption of constant variation is of the error term is not constant. If heteroscedasticity exists, my OLS estimators will be still linear, unbiased, and consistent, but not efficient. And if they're not efficient, then we say they are no longer blue estimates. Hence, as a consequence, they are not blue estimates. Now the question is, how do we diagnose heteroscedasticity. And if we come across with the heteroscedasticity, then what steps we should take care of heteroscedasticity. So if my variance is not efficient, then I will have a problem in hypothesis testing and confidence interval estimation. How we deduct, or how do we know whether our model is suffering from heteroscedasticity or not? We have a number of tests. Widely used tests are Bruce-Pagan test and the White test. This is called BP test, and this is your White test. These are the two important tests which are widely used for testing heteroscedasticity in the model. Others are not that important, so we will not talk about them. These are two important indicators of heteroscedasticity in the model. Okay, so let me take an example and see how can we do it in Gretel. And yesterday I have already shared the files. You can open Gretel along with me. Try to do yourself if it is possible. File, open data, user file, violation of assumptions. So let me take first cost quantity data for normality test. So we have the total cost as a dependent variable, and we have the quantity of this. How do we check normality? If you remember, go to tests. There
Via
is a
histogram.
normality of residual, and you see this is the graph which you have. And look at this p-value, which is less than 5%. That means the distribution is not a normal distribution. As I said earlier, one of the option is you can transform your data and you know run the model again. So for example, if I take log of quantity instead of quantity, then let's see what happens. That's normality. And if you see the p-value is 0.7972762, that means what? My distribution is a normal distribution. So it might be possible that if you transform your data, your distribution may become normal distribution. So friends, how you will test normality, you have already seen in it. Now let's see whether this model is having heteroscedasticity or not. So go to tests, heteroscedasticity test, Bruce-Pagan test, p-value is 0, 0. That means the distribution is having heteroscedasticity. You can also make use of white test. Go to test, white test, 0, 0. That means distribution is having heteroscedasticity. Variance of the error term is not constant. So the estimate which we get, they are not efficient estimates. Okay, so whatever model you take, let me take one more exercise so that you feel comfortable with it. I go to File, Open Data, User File, Data Files, Violation of Assumptions, File for Heteroscedasticity, ordinary X is my independent, Y is my dependent. Okay, I go to test, heteroscedasticity, Bruce-Pagan test. Result is coming to be, the p-value is coming to be 0.004. Null hypothesis rejected. That means the distribution is not homoscedastic. Distribution of error term is heteroscedastic. Heteroscedastic. It means the error term does not have a constant variance. So friends, I hope by making use of Gretel, you can check whether we have a heteroscedasticity problem or not. Okay, what we do when we have a heteroscedasticity, the easiest way, the comfortable way is derive what is called white heteroscedasticity, consistent, standard errors, or covariance. This is also called robust error. Another is use generalized or weighted least square method. This normally we don't do, or you can deflate your variables by taking log or by taking reciprocal and thereby remove the heteroscedasticity from the model. But I tell you, friend, the best way is take robust errors. So if I take robust error, the problem which is arising because of heteroscedasticity in our standard errors, that will be taken care of and you should not worry about it. How do we do it in Gretel? Simple. This is the model which we have. Edit, modify model. Do you see this robust standard errors? HC1, heteroscedasticity consistent estimate. You say okay. If you compare these two models, you will find the coefficient value is same, but the standard errors are different. 2.70, 3.05, 0.1766, 0.250. So the problem that is arising because of the heteroscedasticity in the standard errors, that has been taken care of, and you did not worry about your results. Okay. Let me take one more example to illustrate the same. We have filed for heteroscedasticity. So my model is the distance traveled by the family. So distance traveled by the family is my dependent variable. How much distance a respondent will travel depends upon the age of that person, income of that person, and the number of kids in the family. Okay. Then test heteroscedasticity, Brushpagan 00. That means my model is suffering from heteroscedasticity. What should I do in that case? Simple. Go to edit, modify model, click on the robust standard error. And this is a model which has taken care of the problems which are arising because of heteroscedasticity. And you can see here heteroscedasticity, robust standard errors. Okay. Now let's move to another. What if my error terms are correlated? If my error terms are correlated, then we have a problem, what is called a autocorrelation problem. If the error terms are correlated or having covariances among them, which is not zero, then we have a problem, zero correlation or autocorrelation. And friend, this problem is very prevalent in case of the time series and not in the cross-sectional data. And we normally don't discuss autocorrelation problem with the cross-sectional data. So whatever we have discussed so far, that is related to cross-sectional data. And in the cross-sectional data, we cannot prove or test our autocorrelation problem or serial autocorrelation problem. What if our independent variables are correlated? X1 is correlated with X2, for example, correlated with X3, X4. X2 is correlated with X1, X3, X5, for example. So if this kind of correlation exists, we say we have a problem which is called, anyone, what is this problem called? Multicollinearity problem. If the covariances between the independent terms is not equal to zero, then we have a problem which is called multicollinearity problem. If the intercorrelation among the explanatory variable is perfect, when I say perfect, that means it is either plus 1 or minus 1, then we cannot estimate the coefficients of the model as they become indeterminate, and we cannot get anything from that particular model. So what many software does, they give you a message that solution is not possible. Many times, you know, software throw away those variables which are creating autocorrelation problem and give you the result for the remaining one, which are not creating autocorrelation problem. So you have to see what exactly the software is doing with your data. Okay. So when multicollinearity exists, estimates become unstable and unpredictable. R square is high, but none of the coefficient is significant. That's one of the important indicator of multicollinearity problem. High R square, but none of the coefficient is coming to be significant. OLS estimators and their standard errors can be sensitive to small changes in data. And how do we test? We test multicollinearity by a parameter which is called VIF, that is called variance inflation factor. And that's how we calculate variance inflation factor. There is the rule about VIF. So it's very, very hard to find no correlation among the variables. Some amount of correlation does exist between the variables. You cannot say that you have two, three variables in your model, correlation is zero. That is just not possible. Some correlation is bound to exist. In that case, what we do, we have a benchmark threshold, which is decided by the thumb rule, and that is 10. So if VIF is greater than 10, we have a serious multicollinearity. If it is less than 10, then we can ignore the problem of multicollinearity. So again, that's very simple. You just check whether we have VIF more than 10 or less than 10. More than 10, multicollinearity problem exists. Less than 10, multicollinearity problem does not exist. And if there exists multicollinearity problem, then question arises either what is solution for it? If your purpose is only prediction, ignore it. You may drop the variable which is creating multicollinearity problem, or you may transform the variables, or you can identify some underlying factor which are which are creating factors which are independent of each other and does not create linear relation between them and does not have multicollinearity problem. Okay.
Sir, I have a question.
Yes.
Uh,
Yes,
sir,
Renu.
yes, sir. Sir, transforming the variables here, what does it mean? Like to convert the same into log as we did
Maybe
in
you
previous.
can do it in log, or you can take a square of it, you can take reciprocal of it.
Okay, okay. Means not only log, anything, right?
Yes, you can do other.
Okay, sir. Okay.
What is the correlation between x and x square? Yes, Renu. What is the
Sir,
correlation between x and x square?
sir, in terms of positive or negative?
Yes.
Sir, x and x square, it's remains same. Means like positive only.
Correlation is 0.
Okay. Oh, I got it now, sir. Means when
Why?
we
Why 0?
because each and every thing is transformed in same way, and the function which works on it, it computes the value which comes to be zero. There is no significance of squaring the value.
What is correlation? Correlation is a measure of linear relation. Isn't it? When we talk about correlation between two variables, we are measuring linear relation between the variables. But here the relation is not linear, relation is non-linear. As a result, linear relation is 0.
Okay, sir.
So if you have x square in your model, then theoretically speaking, your model is not having multicollinearity problem. Okay.
Okay, sir.
Renu, what is the area in which you are working?
Sir, my area is related to carbon finance
Okay.
under SK Sinha, sir, Professor SK Sinha, sir.
Okay. So in that case, you might be using regression.
Sir, actually, right now I have not the access to data. Means I'm not at that particular stage. So,
Okay.
right now I am at the stage where I'm working on my model.
Okay.
So, all these things I think I will be using in when I have the data with me.
But what is the model you are planning to work on? Is it a regression model or not?
No, sir, not right now. Actually, right now I'm studying about the literature from in which the model has been used and how I can work on it.
Okay. So the literature which you are studying, are they using regression model or not?
So some not.
Okay.
So basically, main of the models which I have went through all are conceptual till now.
Hmm.
So regression I found I think very less.
Okay. So let's see how do we check multicollinearity problem in Gretel. Suppose this is the model which we have, and we have this is the model which we have age, income, and number of kids. And to avoid heteroscedasticity, I am taking the standard error, which is robust standard error. Okay. You go to analyze, and in analyze you have the collinearity. Click on it. Variance proportion is 0.5 associated with a condition of 10. If it is more than 10, then we say we have a serious problem. Otherwise, we do not have a serious problem. Let me check if we have something else. So go to analysis, collinearity, and this is the test which you have. Variance proportion is greater than equal to 0.5 associated with the condition this, and this is 0.966. That means our VIF is less than 1. And what does it say? Variance inflation factor, minimum possible value 1. And if values are greater than 10, may indicate a collinearity problem. Age is having VIF of 1.2, income 1.060, number of kids 1.38. Since they are all less than 10, therefore, we do not have any multicollinearity problem. Let me take an example where we have multicollinearity problem. So the capex of a company depends upon the profitability of the company and the size of the company. And now, very interesting thing you will find here. RH square is 75.88%, but none of the variable is coming to be significant. That clearly indicate that our model is going to have a multicollinearity problem. You can also calculate variance inflation factor, collinearity, variance inflation factor. Look at this, 145.378, 145.378. Much higher than 10. Therefore, our model is having serious multicollinearity problem. What is the way out? One way out is you drop one of the variable. Suppose I drop one variable, say profit, then size is coming to be significant, and my RH square is 73.2991. Okay, you can also test or check instead of size. If we take profit as now I ask you, I have to drop one variable, right? So which variable I should drop? Profit or the size? Both the variables are coming to be significant. Anyone who will give me the answer, which one I should prefer? What we look at, RH square. Whose RH square is higher? When you take size, RH square is 73.29. And when I take profit, my RH square is 75. So since by taking profit, I get better explanation. So if I have to drop, it's better to drop size from the model rather than profit from the model. Okay? So that's how you can think of taking care of multicollinearity problem. So friends, please remember important thing. If your all assumptions are correct and they are true, then Your OLS estimate are the best estimates. Nobody can question them. But if the assumptions are not true, then there is a question mark on the reliability or the conclusions which we are deriving from our regression model. So, what to do? Test. And we have discussed tests for different conditions. And we have also discussed the solution for each problem. So, friend, whenever you do any regression, please test the assumptions. And if assumptions are not true, what is to be done? Do that so that you get the acceptable conclusions. Any questions or any doubt about whatever we have discussed so far? Nishant says no. Prachi, are you there? Okay.
सर एक्चुअली
Yes,
क्वेश्चन ये कि
Prachi.
जो ग्रेटल ये ऐप जो ये ग्रेटल ऐप है सर माय वॉइस इज ऑडिबल
Yes, yes, you are.
हेलो सर माय क्वेश्चन इज कि जो ग्रेटल ऐप है ये जो ऐप है इसमें क्या डिफरेंस है और जो बाकी स्टैटिस्टिकल जैसे एसपीएस है आर है मतलब मैंने फर्स्ट टाइम ये ऐप का सुना है ग्रेटल
ठीक है
सो डिफरेंस क्या
तो
है
मैं
सर इस
बताता हूँ डिफरेंस क्या है. पहला तो यह है कि जो ग्रेटल है वो फ्री है, ओपन सोर्स है. आप डाउनलोड करो, यूज करो. कोई ट्रायल वर्जन का कंसेप्ट नहीं है. जितने दिन आप रखना चाहते हो रखो और कहीं से भी यूज कर सकते हो ऑल ओवर द वर्ल्ड. ठीक है. ये मिनट ड्रिवन है. आर जो है वो मिनट ड्रिवन नहीं है. आर में आपको कोड्स लिखने पड़ेंगे, प्रोग्राम लिखना पड़ेगा टू रन द रिग्रेशन. इसमें कोई कोड्स नहीं लिखना, कोई कमांड नहीं लिखनी. आपको जस्ट क्लिक 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 करके रिजल्ट निकालने हैं. तो और कोई फर्क नहीं है इसमें. रिजल्ट सबके सेम आएंगे. ठीक है.
तो लाइक जैसे मेरी प्राइमरी स्टडी है तो उसके लिए तो ग्रेटल यूज नहीं हो पाएगा क्योंकि जैसे अगर
किस चीज की स्टडी
मेरे
है?
को सर प्राइमरी स्टडी है मेरी
हाँ, प्राइमरी डेटा में नहीं लगेगा. प्राइमरी डेटा में
हाँ
अगर आप
जी
2 वेरिएबल्स का रिग्रेशन करोगे तो यूज होगा, वरना यूज नहीं होगा. अगर प्राइमरी डेटा में आपको किन्हीं वेरिएबल्स का रिग्रेशन करना है तो ग्रेटल यूज कर सकते हैं, अदरवाइज ग्रेटल यूज नहीं होगा. ठीक है.
यस सर
Anything else? Anybody else? Regression is primarily for secondary data analysis and not for the primary data. I'm saying primarily it is for secondary, but there may be cases even in the primary research you can make use of regression. Okay. So let's see what next we are going to talk about. Take you to the interesting world of the time series, because I have a special request that we should talk about time series. So let's devote what is time series and how do we go about it. Sorry. The system is hanged, so I'm going to restart it again. I do not know how many of you are going to make use of time series data. Anyone who's going to use time series data?
So maybe in future.
रेडू, तुम्हारे केस में हो सकता है कि टाइम सीरीज डेटा हो.
Yes, sir, because right now I am not aware how to go with. So
हाँ.
might be मेरे केस में हो.
Sir, good evening, sir.
Good evening. Yes, Aman.
मेरी स्टडी में भी है सर, टाइम सीरीज डाटा एनालिसिस होगा।
क्या है टॉपिक?
एफिशिएंसी ऑफ इंडियन कैपिटल मार्केट।
यस, तो तुम्हारे केस में तो टाइम सीरीज यूज ही होगी, क्योंकि
हाँ
जो
सर।
डेटा है वो मार्केट का डेटा होगा, और
जी सर।
मार्केट डेटा में आपको टाइम सीरीज डेटा लेना पड़ेगा।
जी सर।
तो अभी काम करना शुरू किया है या क्या है?
नहीं सर, अभी काम नहीं करना, स्टार्ट नहीं किया।
अच्छा,
रेनू मैडम है, उसके साथ ही हूँ सर।
तो रेनू तो उस पे ग्रीन फाइनेंस पे,
सर हम सेम बैच पीएचडी स्कॉलर्स हैं।
तो तुम्हारा तो ग्रीन फाइनेंस है ना?
हाँ सर, मेरा कार्बन फाइनेंसिंग है, अमन का टॉपिक दूसरा है। मतलब हम प्रोफेसर एसके सिन्हा सर के अंडर ही हम दोनों स्कॉलर्स हैं,
हम्म,
और हमारा सेम ईयर का एनरोलमेंट है और सेम स्टेज पे है हम लोग।
पर एरिया तो अलग अलग है ना
हाँ मैं
रिसर्च
हाँ
का।
हाँ
हाँ
सर,
सर, एरिया
हाँ
अलग अलग।
एरिया अलग अलग है सर।
हाँ, तो अमन का तो क्लियरली टाइम सीरीज का डेटा है।
जी सर।
सर मेरे केस में मुझे ये प्रॉब्लम आ रही है सर, अभी ना जैसे ये टॉपिक बहुत न्यू है और अभी बैंकिंग इंडस्ट्री में ये इतना एप्लीकेबल नहीं है मटेरियली, तो उससे रिलेटेड डेटा लेना थोड़ा सा मुश्किल हो रहा है। कई बैंक्स फॉलो कर रहे हैं, कई कर ही नहीं रहे हैं, क्योंकि
अरे जो
अभी तक।
फॉलो कर रहे हैं तो उसमें लोगों को पता भी नहीं है कि वो ग्रीन फाइनेंसिंग कर भी रहे हैं कि नहीं कर रहे हैं।
यस सर, मैंने रिटेल बैंकिंग पे जाके बैंक्स में जाके
उन्हें
पूछा
पता ही
तो
नहीं, उन्हें नहीं पता होगा।
नहीं सर, उनको ग्रीन फाइनेंस भी नहीं पता, कुछ नहीं, वो बेसिक अपने लोन्स पे चल रहे हैं। फिर अब ये जाके फिर मैंने आरबीआई भी विजिट किया था, तो आरबीआई ही में ही एक ऑफिशियल ने मुझे कहा कि मैम आपका जो टॉपिक है वो बहुत ही ज़्यादा न्यू है, अभी तो इसमें हमने बैंक्स को भी डायरेक्शंस नहीं दिए हैं, वो आपको क्या ही डेटा देंगे। सो अभी मुझे सर इसी प्रॉब्लम को टैकल करना है कि
तो
मीन्स मैं
आरबीआई की कौन सी ब्रांच में गए थे? दिल्ली वाली?
सर दिल्ली में, मैं दिल्ली में ही हूँ सर, तो दिल्ली में ही गई थी मैं
कहाँ रहते हो?
सर, पंजाबी बाग,
अच्छा, ईस्ट वेस्ट?
द वेस्ट।
ओके।
सो अभी मेरे को खुद फिगर आउट
ये
करना है।
रेनू श्यामा प्रसाद मुखर्जी में रेगुलर टीचर है कॉमर्स डिपार्टमेंट की।
ओ,
हाँ,
रेनू ये नहीं बता रही हो तुम कि श्यामा प्रसाद
सर मैं स्कॉलर ही हूँ सर, इसलिए अभी
और मेरे अंडर में वो पीएचडी कर रही है, बट शी इज रेगुलर असिस्टेंट प्रोफेसर इन श्यामा प्रसाद मुखर्जी परहैप्स 2007। कब से हो?
सर 2012 में हूँ, और मेरा पहला प्रोग्राम सर मैंने आप ही का अटेंड किया था, सीबी गुप्ता सर का, प्रोफेसर का, जब रामानुजन कॉलेज में सर आपने लिया था, रामानुजन
अच्छा।
कॉलेज के साथ था,
अच्छा,
तो मैं तब से मतलब
तो तुम कॉलेज के पास ही रहती हो?
सर मैं कैंपस में ही रहती हूँ।
अच्छा।
हाँ हाँ, स्टाफ क्वार्टर्स हैं सर उसी में।
बढ़िया है फिर तो।
यस,
हाँ,
थैंक यू सर, थैंक यू सो
चलो,
मच।
तो तुम तो फिर हमारे साथ टच में रह सकती हो, कोई दिक्कत नहीं है।
सर बिल्कुल सर, मैं वही सर का, सिन्हा सर ने प्लेटफॉर्म दिया सर कि आपसे इस तरीके से बात हो पाई।
So let's take you to the word of time series. But what is a time series? अमन, टाइम सीरीज क्या होती है? अमन कहाँ गायब हो गई?
यस सर।
टाइम सीरीज क्या होती है?
collection of data that tracks a variable over the time.
अमन, ये डेफिनेशन हम आजकल यूज नहीं करते हैं।
ओके सर।
हमारी जो डेफिनेशन है वो है, इट्स ए रियलाइजेशन ऑफ ए स्टोकास्टिक प्रोसेस। फ्यूचर में क्या होगा किसी को नहीं पता, एक प्योरली रैंडम प्रोसेस चल रहा है, स्टोकास्टिक प्रोसेस चल रहा है।
जी सर।
उसका जो एक पर्टिकुलर वैल्यू हमें मिल रही है वो हमारे लिए टाइम सीरीज है।
ओके सर।
तो इफिशिएंसी के अंदर क्या अजम्पशन होती है, कौन सा प्रोसेस होता है मार्केट में?
देयर इज
random walk.
random walk hypothesis.
तो अगर मार्केट में इफिशिएंसी है तो वहां जो स्टोकास्टिक प्रोसेस होगा
हाँ सर,
वो रैंडम वॉक होगी, और टाइम सीरीज जो है वो उसका एक रियलाइजेशन होगा जो आपको दिख रहा है.
जी सर.
That's how we define a time series. Say, for example, my prices are following normal distribution. So tomorrow it can have any price. Okay. From that normal distribution, day after tomorrow, anything can happen on any day. I don't know. But I know that the distribution of the prices is a normal distribution. But at the end of the day, I just pick up one value. Okay, so one realization I get. So, for instance, this is the value I get at the end of the year, end of the day. This is the value I get at the end of the day. Out of infinite values, I get this is the value at the end of the day. Similarly here, so if I take a collection of all this data, that will give me what is called time series. So the collection of the points which we have realized
जी
is called time series. Let me take another example. Suppose this is the price which can happen today, tomorrow, day after tomorrow, and so on. I do not know what price will be there, but I know that it will be a normal distribution. So at the end of the day, I get one value out of many possibilities, like this. And if I take a collection of these points, then this will be called a time series. So define time series as a realization of stochastic process. It's a realization out of infinite possibilities. And this one realization is the result of some underlying stochastic process. And that's why we say we are having realization of a stochastic process. अमन, और भी कोई है इस पार्टिसिपेंट में जो टाइम सीरीज पे काम कर रहा हो?
सर मेरी फ्रेंड का है एक बिहेवियरल फाइनेंस, उसमें होगा यूज?
पता नहीं वो क्या डेटा, क्या पार्टिसिपेंट है वो?
हाँ सर.
क्या नाम है?
मनेहा सहारन सर.
है
मनेहा सहारन.
मुझे नहीं पता वो बिहेवियरल फाइनेंस में क्या कर रही होगी.
क्योंकि सर पांड्यान की बुक में जब मैं पढ़ता हूँ ना एफिशिएंट मार्केट हाइपोथेसिस.
हाँ बोलो बोलो. अपन बोलो क्या कह रहे थे? So visualize that there is some process which is a stochastic process, and that stochastic process is generating, one realization out of many, and that one realization is my time series. A realization of a particular stochastic process is called a time series. Every realized observation of a stochastic process is understood as a time series. And Aman, in your case, if the markets are efficient, the process is random walk process, which is a
जी
stochastic process. And what you will get in time series, one observation, one realization of that random walk process. Okay?
यस सर
वो पार्टिसिपेंट तो नहीं है तुम्हारी जो फ्रेंड?
थी सर, अभी वो लेफ्ट कर गई होगी शायद कुछ।
अच्छा,
हाँ
उसके केस में हो भी सकता है, उसके केस में नहीं भी हो सकता है। वो डिपेंड करता है कि वो जो है किस तरह का काम कर रही है। तुम्हारे बैच की है?
जी सर।
अच्छा. So time series, as I said, is one of the realization of the stochastic process. How do we understand the behavior of time series? So we have two options. One option is make a time series plot. Another option is make a correlogram. Like this. This is a time series. And you can see what is the behavior of this particular time series by making a graph of it. See? Another behavior you see in case of time series. So how the time series is behaving over a period of time, you can get that idea or the feel if you make a graph of it. Another tool to understand the behavior of the time series is correlogram. Correlogram is a plot of the autocorrelations and partial autocorrelations versus time lag of a time series. So you have a time lag. You have autocorrelation function, which may be something like this, or partial autocorrelation. Like this. So by looking at the pattern of the correlogram, we can analyze or we can understand the behavior of the time series. Like here, these are the limits. Outside limit is 1, 1, and that is the autocorrelation. AC is the autocorrelation. PAC is the partial autocorrelation. So now the question is, what is autocorrelation? And what is partial? Autocorrelation. What is the meaning of auto? ऑटो को क्या मीनिंग होगा? अपने साथ जो कोरिलेशन है. तो अगर मान लीजिए मेरे पास सेल्स डेटा है, ठीक है, 90, 90, 91, 92, 93 and so on, with data of 200, 225, 210, 230. और मैंने सेल्स का 1 लाख पीछे लिया है, ठीक है. So this will be a, so suppose 1 लाख पीछे लिया है, तो इस केस में होगा 200, इस केस में होगा 225, इस केस में होगा 210. Just give me a minute. तो क्या हो रहा है इस केस में, मैं सेल्स का कोरिलेशन निकाल रहा हूं सेल्स के लैग के साथ. So I'm calculating correlation of sales with these sales but with the lag. Then I'm calculating what is called autocorrelation. So autocorrelation is correlation of the series with its own with a lag. Lag may be 1, lag may be 2. If it is lag 2, what does it mean? This will be 200. This will be 225, like this. Right? So how time series is correlated with each other over a period of time, that we can get an idea by looking at autocorrelation. Okay, then you have what is called partial autocorrelation. '90, '91, 1992. Suppose I'm calculating a correlation with 1 lakh. That means 90, starting with 90 and starting with 91. So what does it mean? I'm calculating simple correlation, simple autocorrelation. Okay. But if I want to calculate with 1992, 110, sorry, 1990, in between we have 1991. So what to do with this in between number? We have two options. Ignore or filter out its effect. I hope you understand what I'm saying. If we have something in between, what to do with that in between number? One option is ignore, forget 191, 1991 tha, chhod do. Another is no, it's very important for us. We have to filter out the effect of this from the relationship between 1990 and 1992. So if we ignore it, we get autocorrelation. If we filter out the effect in between, we get what is called partial autocorrelation. So partial autocorrelation means correlation between two legs of a series, eliminating the effect of in-between numbers. Okay, so what does it mean? Again, I'm saying you have a yt plus 1, yt plus 2. If I'm calculating correlation between this and this, eliminating the effect of yt plus 1, then I'm calculating what is called partial autocorrelation. So friends, I hope you understand the difference between autocorrelation and partial autocorrelation. Autocorrelation is a simple correlation between xt and xt plus h. So I'm not caring what is in between t and t plus h. I don't care for it. But in case of partial autocorrelation, it's a correlation between observation xt and xt plus h after removing the linear relationship of all observations that fall between xt and xt plus h. बीच वाली टर्म्स का इफेक्ट हटा दिया तो पार्शियल, अगर इफेक्ट नहीं हटाया तो सिंपल ऑटो कोरिलेशन. ओके. So now let's see what next we are going to talk about. And nothing, let's take a 5 minutes break and I have to share the files with you people. And then again, we will come back to our discussion on time series. So let's have a 5 minutes break. After the 5 minutes break, we will come back and meet again.
Sir, your mic is off. Sir, we are unable to hear you.
I'm sorry. Thanks, Renu, for reminding me. So I was asking the question, is it possible? Okay. Yes. Now I think you can hear me. So I was asking a question, is it possible for me to use OLS for the time series data? The answer is no, we cannot, because our time series shows autocorrelation and heteroscedasticity. Because of this violation of the assumptions, we cannot use OLS for our time series data. So what we should do, that is something which we have to discuss. OLS works when its assumptions are true. Many times time series data does not satisfy the assumptions of homoscedasticity and no autocorrelation problem. Because of this violation of the assumptions, we cannot use OLS. And if we try to use OLS, we will not get the best estimates. We will not get the blue estimates. So if OLS cannot be used, what all can be used, that is something which we are going to talk about. But before that, we have to ask something very important. Who is the culprit behind making our results of OLS spurious? When I say my results are spurious if they are meaningless, if they are having no sense, then we say we have spurious correlation or spurious regression between the series. Okay? And the culprit is a non-stationary series. When time series are non-stationary, you cannot work with it. And if you work with non-stationary series, your results will be spurious results. So friends, lesson number one, if you are working with the time series, make sure that your series is not a non-stationary series. Your series has to be stationary. So when I talk about stationary, non-stationary, then the question arises is what is stationary? What is non-stationary? If we work with a non-stationary time series, then we get spurious regression. Meaningless regression. To avoid spurious regression, we must ensure that our series is stationary. And that takes us to discussion of stationarity and non-stationarity. We have two types of stationarity, weak and strong. So now let's understand what is weak stationarity and what is strong stationarity. A series is said to be weakly stationary if it has constant mean, constant variance, and the covariance function depends upon time difference between the values of the variables. So basically what we are saying, mean constant, variance constant, and if I'm calculating covariance between yt and yt plus 5, it will always be a constant number if I take a leg of 5. So when a series shows these characteristics, then we say that series is a stationary series. On the other hand, a series said to be strongly stationary if the joint probability distribution of the observation is same over all the time period. Weakly, mean constant, variance constant, covariance constant. Strong, mean constant, variance constant, skewness constant, kurtosis constant, covariance constant. Everything is identically distributed. So same distribution over the period of time. No change in the distribution. But in a weekly, I'm not talking about the distribution. What I'm saying, mean should be constant, variance should be constant, covariance should be constant. So in economics and finance, we work with weekly stationary series. We never work with strong stationarity. Always weak. So friends, if somebody is talking about stationarity in the context of finance and economics, please understand he is talking about weekly stationarity. That stationarity where the mean is constant, variance is constant, covariance is constant. Aman, are you there? Aman, are you there? No? Okay. So I think Aman has left.
No, sir, he is in the meeting, but yes, sir, he's there. Some technical issue is there. His mic is also on.
Okay. You know why I'm remembering Aman is if we see random walk in the market, is it stationary or is it not stationary? That's the question which we raise. Anybody, any guess? If a market is following random walk, which is the condition of efficiency, then what do you think? The share prices which we have, will they be stationary or they will be non-stationary? Anybody guess? Nishant, Renu, Prachi, anybody? Random walk is always a non-stationary series. Always, sorry. It is not a stationary series. So when you come across with a series which follows random walk, take it granted that that is not stationary. Okay? Right. Non-stationary. Yes. Now the question is, how do we know whether a series is stationary or not? So we have a number of tests. And let's see what are the tests which we use to check whether a series is stationary or not. We have Dickey-Fuller test, we have augmented Dickey-Fuller test, we have the Phillips-Perron test. Widely and mostly used test for stationarity is augmented Dickey-Fuller test, or in brief, it is called ADF. So by using ADF test, we can find out whether a series is stationary or it is not stationary. And null hypothesis of all these three tests is series is non-stationary. Alternatively, the series is stationary. And many times, stationarity test is also called the unit root test. And these tests are also known as unit root tests. If I talk in terms of the unit root, if the series is having unit root, then it is non-stationary. If it does not have unit root, then we have stationarity. Now the question is, from where we are picking up this definition of unit root? So root means the solution, right? If the solution which we get of our time series is unit 1, then we say our series is not stationary. If it is less than 1, it is not 1, but it is lower than 1, then we say our series is stationary. So in all these cases, the test null hypothesis is the series is having unit root. Therefore, null hypothesis is series is not stationary. Rejection of this null hypothesis will mean the series is stationary. Okay, so let's go to Gretel and see how do we check whether a series is stationary or not. So I have shared some data with Professor Sinha, and I think he shared the data in the group. So we will work with that particular data. So I open file, open data, user file. We have in index data, NSC data. I just open it up. Index data, okay. We have Nifty 50, we have the large cap mid cap, small cap data. Let me take Nifty. If you want to see the graph of it, graph time series plot, Nifty 50, that's the graph which we have. Okay. I want to check whether this is having unit root or not. So go to variable, unit root test, augmented Dickey-Fuller test, and I say okay. Null hypothesis is unit root. That means my solution is having unit root. The solution is equal to 1. And if you see here, 0.06896 and 9599. P values are not significant, and therefore my series is having non-stationarity. Series is not stationary series. So when we run our unit root test, it is asking me test without constant, test with constant, test with constant, and trend. If you see the graph, we have trend as well along with the constant, because even if everything is zero, still we get some price in the stock market. We get some value of the index. So we say with constant and trend. I just copy it from here. I'm just putting that data here. The test is augmented Dickey-Fuller test for Nifty 50. Null hypothesis, the series is having unit root. Series having constant and a trend. P value is this much. On the basis of that, we conclude that the series is having non-stationary behavior. Okay. So let me show you how we are proceeding. We take time series. We try to understand it by making graphs and cologram. Then we check whether the series is stationary or non-stationary. And why do we check for stationarity? Because if the series is non-stationary, and if you do regression, then the result will be spurious. And we check stationarity and non-stationarity by making use of the widely used test, which is called ADF. The next question arises is if time series is non-stationary, what should we do? If my series is not a stationary series, what should we do? Anyone? His friend says, no tension, mere yaar, take difference and then the series will become stationary. By taking difference, we can make the series stationary. Here we have a question. Should we take simple difference or should we take log difference? Anyone who will suggest? By taking difference, by taking the first difference, what first difference means? Change in yt is equal to yt minus 1. This is called first difference because I'm calculating difference by taking one leg. Then the question arises is, should I take a simple difference or should I take log difference? Aman, are you there? Can you speak? Or you can write your response in the chat box. Anybody else? In finance, we don't take simple difference, we take log difference. And log difference gives me what is called log return. So friends, don't take a simple difference, take the log difference to make the series stationary. And how do we do it in Gretel? Let's have a look at it. Very simple if you do it in Gretel. I want to take the log difference of Nifty 50. So go to add log differences of the selected variable, log difference of Nifty 50. I got it. Then if I test this variable for unit root, now by taking difference we are killing trend. So now we have only constant. We say okay. And now you can see the asymptotic p-value is 0. That means now the series has become stationary and you can do whatever you want to do with this stationary series. Okay, let me take another example. We have Nifty 50 mid cap. This is the data which we have. If you want to see the graph, time series plot, that the time series plot. If you want to make a correlogram of it, then you can go to variable correlogram. That's the correlogram which we get. We have ACF, we have PACF here. So it also gives you an idea about how to understand the behavior of the time series. Okay. Now let me check its unit root. P value is 0.999, which means the series is having unit root. It is not stationary. If it is not stationary, then I have to make it stationary by taking log difference. So you say add log differences of selected variables. And now if you take the unit root test of it, now the asymptotic p-value is almost zero. That means the series is now stationary series. So once the stationary series is there, what we can do about it? So friends, check for stationarity. If you find that series is not stationary, take the log difference to make the series stationary. Any questions if you have, any one of you? So once we have made the series stationary, what next we have to do? What is the next thing which you have to do? What next? टाइम सीरीज लिया, उसका ग्राफ बनाया, उसको समझा, उसको स्टेशनरी बनाया, तो अब क्या करें उसका? What should we do about that stationary series? We use that stationary series for what to do after this time series has become stationary. We use stationary time series for forecasting purposes. So we can use forecasting mean and forecasting variance. Now the question is how to forecast mean, how to forecast variance. We forecast mean by using a model which is called ARIMA model. What ARIMA stands for? Autoregressive term. That means yt is equal to alpha plus beta yt minus 1. So yt is regressed with itself, so we call it autoregressive. What is I? I will come back to this I. Moving average means the error term, beta 1, error term of the previous period. So I have autoregressive term 1, MA1, right? What is I? I stands for integrated value. How many times I should take difference to make the series stationary? Difference to make series stationary. So if I say ARIMA 1, 1, 1, that means you take one time difference of the series to make it stationary. And once it becomes stationary, take one autoregressive term and one moving average term, which is nothing but your error term, and autoregressive term is this. So if you write a ARIMA 201, that means no need to take any difference because series is already stationary. Take two terms of autoregressive and one term of moving average. Use this model and make a prediction for the mean of your series. Okay. Friends, we don't have much time, otherwise I could go into details of ARIMA. If you want to predict variance, then we have ARCH and GARCH model. ARCH stands for autoregressive. CH stands for conditional heteroscedasticity. This is something which I can make use for predicting variance. And in this case, I am assuming that what variance we have today depends upon the variance we have yesterday. Because we have what is called a variance clustering property. So if you have variance today, might be today variance, it depends upon the previous day variance. So in that case, we say autoregressive variance of variance with itself. And conditional because it depends upon the historical data, and heteroscedasticity because my variance is not constant. Every day my variance is changing. So my variance is time varying variance or dynamic variance which is changing with time. Okay. Now the question is, what is GARCH? GARCH is called generalized autoregressive conditional heteroscedasticity. So, friends, I do not know how many of you will be interested in the forecasting of the mean or the arch or gauge. If you want to do it in greater, I just show you how you can do it. You go to model, univariate time series, ARIMA model. Okay, so stationary series. Suppose I say ARIMA autoregressive term 2, 3. It is already stationary, so I need not to take the difference of this series. Then I say, okay, that's the ARIMA term which we get. If you want to make a forecast, go to analysis, forecast. Suppose I say, give me forecast for the next 5 days. This, okay. This is the last 5 days forecast. And if you want to see the graph of it, you can see the graph. This 5 days forecast is the forecast as given by our model. right? If I want to do model univariate ARIMA, suppose this time I take this. Suppose I take AR1, MA1, and that's the result which we get. So friends, you can do ARIMA in this way. If you want to do GARCH, so you have multivariate time series. GARCH dependent variable is my log this. GARCH1, ARCH1, include a constant. You say, okay, that's the estimate of it. So that's the way, friends, you can do GARCH in Gretel, ARIMA in the Gretel. And I'm sorry, we don't have much time to discuss in detail the whole dynamics of the ARIMA and the whole dynamics of the GARCH. But if you have any question in your mind, you let me know. I will try to answer that question. And I'm really sorry because the paucity of the time, we could not discuss in detail the dynamics of the arch, GARCH, and the dynamics of the ARIMA. If you have any questions, let me know. Any doubt, any query, if you have. No?
No, sir.
Okay. So friend, that's all from my side. Enjoy, have a good time. Thank you very much to all of you.
Thank you so much, sir. And it was really a wonderful session from last 2 days. We
रेनू
have
मुझे
learned
नहीं
so
पता
much.
कि वंडरफुल है कि नहीं क्योंकि टाइम
नहीं सर
सीरीज
है, the problem is not like, the problem is with us because we have learned so many things, we need to practice it up. यहाँ पे
Yes.
सर इतने सारे न्यू कंसेप्ट्स एंड ऑल थे, दो वी हैड मेंटेन आवर नोट्स एंड ईच एंड एवरीथिंग, बट यस आपने बना ना लर्निंग ही वो है, तो सर उस पे हमें वर्क करना है. योर सेशन
ठीक
वाज
है.
रियली वंडरफुल.
Okay.
Thank you so much, sir.
So
Sir,
thank
now
you. हाँ.
I want to take this privilege to invite Director, Rishabh Educational Society, Professor S.K. Sinha, sir, to give you a formal vote of thanks.
Okay.
Thank you, Renu. First of all, good evening.
Prachi is asking for the PPT, sir. So I will share PPT with you and you can share with the group.
Okay, sir. Okay, sir. Thank you, sir. Sir, good evening, everyone. I am honored to deliver the vote of thanks on behalf of the organizing committee for this incredible 6-day research methodology workshop. First and foremost, I would like to express our heartiest gratitude to our esteemed resource person, renowned financial analyst, Professor C.P. Gupta, for sharing their valuable insight and expertise with us. Your presentation were enlightening, informative, thought-provoking, and we are grateful for the knowledge and skill you have imparted to us.
Thank you very much, sir. Professor
So-
Sinha, thanks for your nice words.
To our event organizer, thanks you for your tireless effort in putting together this seamless and successful event. Your attention to detail, dedication, and commitment to excellence have been remarkable, and we are appreciate all the hard work you have put in to make this workshop success. To the participants, thank you for your active participation, engagement, and enthusiasm throughout the workshop. Your presence has made this event truly special, and we hope that we have found it as enriching and rewarding as we have. Once again, thank you all for being a part of this wonderful occasion. We hope that the knowledge and skill we have acquired during the workshop will benefited you in a future endeavors. I also thankful to treasurer of this Rishabh Education Society, Dr. Rasmi Sinha, and Dr. Surbi Suman. Thank you very much. Thank you and have a great evening. Thank you very much.
My email address I have written here, guptacp@gmail.com. So if somebody want to contact me, they can contact me through email.
Thank you,
Sir,
sir.
I
Yes,
want
sir.
to ask one thing. Sir, is there any good book which the researcher should go through it? Means like
For what?
though for sir learning about this all methods, techniques, each and everything. Though I have a book on testing and all, but from you I just want to know that is the one book that one researcher should go
रेनू,
through
वो
page by
डिपेंड
page.
करेगा कि तुम्हें किस पे चाहिए. टाइम सीरीज के लिए अलग बुक्स हैं
Okay, sir.
और
Okay.
क्रॉस
So, sir,
सेक्शन के लिए
once I
अलग.
finalize my data, then I'll get back to you for the
ओके
book, sir.
ओके ओके ओके
Thank you.
रेनू, थैंक यू. सो थैंक यू सीना जी, नमस्कार, बहुत बहुत धन्यवाद आपका, मुझे दिया पार्टिसिपेंट के साथ इंटरेक्शन का मौका दिया. एंड
Yeah.
आई एम थैंकफुल टू ऑल द पार्टिसिपेंट्स and have a wonderful learning experience all the time whenever you are learning something. So thank you very much.
Thank you, sir.
Namaskar.
Thank you. Namaskar, sir. Namaskar.
Thank you so much, sir. Sir, I would like to request you to